My name is Ranjan Majumdar. In my last tutorial, I explained the functionality of break continuous statement. In this tutorial, I am going to explain the application of break. We all know there are multiple types of numbers: even number, odd number, Armstrong number, palindrome number, perfect number, amicable number, and prime number. Today in this tutorial, I will explain the prime number, and the remaining numbers are your tasks, or you can say assignment. If you need any help from me, please comment me. I will help you to solve the problem. Okay, at first I am discussing all numbers. Even number. If a number is divisible by 2, then this number is called even number. If a number is divisible by 2 and if the remaining is 0, then this number is called even number. If a number is not divisible by 2 and if the remainder is 1, then it will be called odd number. In case of Armstrong number, I am writing an example of Armstrong number 153. If I cube up individual number, then 1 cube plus 5 cube plus 3 cube, if you summation all these numbers, you will get 153. Then this type of number is called Armstrong number. By the way, 370 is an Armstrong number, 371 is an Armstrong number. Palindrome number. If you rotate a number or reverse a number, suppose I have 121. If I reverse the number, then you will get 121. Such type of number is called palindrome number. Next, perfect number. Suppose you have 6. If the summation of all factor is equal to the number, then this number is called perfect number. Here, in case of 6, the factors are 1, 2, 3. So, summation of 1 plus 2 plus 3 is 6. By the same way, 28 is a perfect number. Factors are 1, 2, 4, 7 and 14. So 1 plus 2 plus 4 plus 7 plus 14 is equal to 28. Amicable number. The next number is amicable number. At first I am writing an example of amicable number 220, 284. Here you can see 220. The summation of all factors of 220 is equals to 284. Again, the summation of all factors of 284 is equals to 220. If a developer gets such pair, then this pair is called amicable number. I think you have understood. And the last number is prime number. What is prime number? If a number is divisible by 1 or itself, then that number is called prime number. Today I will explain the programming of prime number. So without wasting time, I am concentrating on programming of prime number. First, I am writing a for loop. Here I am using var I equals to 1, I less than 100, I plus plus. I am using curly braces. Again I am using var j equals to 2, j less than equals to I by 2, j plus plus. Again using curly braces. Here you can see I have used var in for loop. That means within for loop. You can also see var j equals to 2 within inner for loop. A developer can write var outside of for loop just like this. But I have written within for loop. What is the meaning of this? This is called dynamic initialization. And again you can see I have written j less than equals to I by 2. That means in condition I have used I by 2. Why? Suppose I am taking a number. The number is 8. The maximum value by which a number is divisible, that means 8 is 4. That is half of the original number. Again I am taking another number, 100. Okay, here I did a mistake. I am using less than equals to 100. Another number, 100. The maximum value by which 100 is divisible is 50. So there is no meaning of iteration from 51 to 100. It is basically wastage of memory and wastage of time. In my previous tutorial, that's my last tutorial, I explained the time complexity. That is the reason I am showing you this example, this prime number. So if you want to be an efficient JavaScript programmer, you must keep in your memory the topic, that is time complexity. Okay, here I am writing if I modulo j 0. That means if a number is perfectly divisible by a value and showing 0 as remainder, then this number cannot be a prime number. Suppose 8 is divisible by 2, perfectly divisible by 2, or showing 0 as output. So 8 is not a prime number. But 5 is not divisible by any number. It is divisible by 1 and itself. Then 5 is a prime number. So here I am writing flag equals to 0. Okay, what is flag? Here I am initializing flag variable where flag equals to 0. And I am writing comment. Okay, you must remember this is the way by which a developer can comment a text. Here I am writing not prime number flag. This line will not create any problem at the time of interpretation. Understood? So this is basically used for comment, and this is called single line comment syntax. Flag 0 is the indication of not a prime number. Here I am using break. Why do I use break? Suppose I am taking a number. That number is 22. So the maximum value by which 22 is divisible is 11. But look at the syntax. In j equals to 2, on very fast iteration, if I use 22 modulo 2, then it will show 0 as output. That means flag is 0. That means this number on very fast iteration, I have found that this number is not a prime number. So there is no need to check the next iteration. On the very first iteration, I have got that this number 22 is not a prime number. So we do not need to check any other iteration. That means we do not need to check 22 modulo 3, 22 modulo 4. That is the reason I have used break. Because on the very first iteration, I have found that number 22 is not a prime number. By the same way, if I assume 50 modulo 2 and the maximum value is here 25, that means I am going to iterate from value 2 to value 25. But on very first iteration for j equals to 2, I have found that the value 50 is not a prime number. So we do not need to check any other iteration. That is the reason I have used break. What is the functionality of break? And it will skip from the inner for loop. And if it is not divisible, then I will write flag equals to 1. Suppose I have a number number 5. So the maximum value is 2. Maximum value by which the number 5 is divisible is 2. So on very first iteration, 5 modulo 2 is showing 1, not 0. Then flag will be 1. Suppose I am taking a number. The number is 17. So the maximum value by which 17 is divisible is 8. So you can see the total number iteration will be from J2 to J8. 2, 3, 4, 5, 6, 7, 8. Okay, now on first iteration, 17 modulo 2, it is 1, not 0. So here flag will be 1. Second iteration, 17 modulo 3, 3 into 5, 15. So the remaining part will be 2. In this case, flag will be 1. Again, 7 to modulo 4, 4 into 4, 16. Remainder is 1. So flag will be 1. By the same way, 17 modulo 5, remainder 2. 17 modulo 6, remainder 5. 17 modulo 7, remainder 3. 17 modulo 8, remainder 1. So in all cases, you have got a value which is greater than 0. In all cases, the flag will be 1. That means it is a prime number. Now, here you can see this is inner for loop. So within outer for loop, I am writing if flag equals to 1, then document dot write I. Document dot write space. I am saving it. Okay. Now you can see there is a mistake. Where is the mistake? Okay. Suppose here the value of I is 17. I have checked that is value is prime number. I have already printed the value of I have already printed the value 70 in document. Now it will again rotate to outer for loop. So here the previous value of flag is 1. By this case, all value will be show 1. That means all value will show prime number. That is the reason when I am going to start the outer for loop, I have to set flag equals to 0. That means in all cases, at first I will assume that this value is not a prime number. After completion of line number 29, we will get assurance that this number is prime number or not a prime number. That is the reason I have used flag equals to 0 at the starting point of outer for loop. I am saving it. Opening the web page. Click the button. Now you can see 5, 7, 11, 3, 17, 90. Okay, it is not showing 2 and 3. So I think there is a mistake. It is showing wrong output. Here 2 and 3, these two values are not showing. 2 and 3, these two are prime number. I am refreshing and click the button. You can see the error. Here I cannot see 2 and 3. 2 and 3 are also prime numbers. 2 and 3 are prime number value. Here I did a mistake. Where is the mistake? Okay. I am setting flag equals to 1. At first, I am assuming all values are prime number. That is the reason I have set flag equals to 1 here. Again, Within inner loop, I am setting flag equals to 1. At first, I am thinking all values are prime number. Now you can see here I have written var j equals to 2. If a developer uses j equals to 1, then it will not show any output. Why? Because in all cases, a number is exactly divisible by 1. That is the reason I have to start. That means we have to start from 2. That means the initial value of j will be 2. Now, here if I modulo j, it is flag equals to 0, it is okay. Else flag equals to 1. So, in this case you can see I value is 1. Suppose I value is 2. 2 is the prime number, you all know. Suppose I equals to 2. Here 2 by 2 means 1. J equals to 2 colon j less than equals to 1. That means 2 less than equals to 1. The logical value of 2 less than equals to 1 is false. So for I equals to 2, this for loop, the code of this for loop will not be executed and it will skip this for loop and come to this. It will come to this line number 30. Here it will check if the flag is 1, then that value will show in output. Here you can see on first statement I have written flag equals to 1. So for I equals to 2, flag equals to 1, then 2 will show in output section. By the same way, for I equals to 3, j 3 by 2, that means 1.5 in JavaScript. So you can see the initial value is 2. 2 less than equals to 1.5. Is it true or false? It is definitely false. So again, this for loop, the code of this for loop will not be executed. It will skip the for loop and come back to the line number 30. Again you can see flag equals to 1, then 3 will be printed or 3 will show in output section. Now I think I did another mistake here. Here the initial value of I will be 2. It will not start from 1 because 1 is not a prime number. We all know that 1 is not a prime number. I am saving it and refreshing the web page. Click the button. You can see the all prime numbers here. Okay. In case of outer loop, you can see the initial value of I is 2. It will not start from 1 because we all are checking the prime number with the criteria. If a number is divisible by 1 or itself, then this number is not a prime number. So the first criteria is if it is divisible by 1. That is the reason I have not used 1 here. Even that is the reason I have not used that number here. That is the reason I have divided the original number by 2 to get the perfect output, and it will maintain all the criteria. This is the end of prime number programming. If you have any doubt regarding this tutorial, please comment me. If you have understood and like this tutorial, please press the like button. If you have not subscribed my channel till now, please subscribe my channel and send this tutorial among your friends and colleagues. Thank you.